This video, you're watching the first lesson on graphs. This unit will talk about how graphs are used, the types of graphs that are available, and how to tell when and how to use certain types of graphs. So uh, we're going to start with the question of what are graphs for. And so when you look at these graphs, what do you see? What information do you get from them? Right? We're looking here at mileage and densities, right? And so these are different values given at different mileage, so different densities at different mileages. And then we have apples sold here, and we have different line graphs showing the change over time in years. We also have, let's just say, preference to certain pets, and we have fish and dogs and cats and hamsters. And you can see this is a pie chart that shows people's preference. And we also have this being a pictograph showing similar information to the line graph, but using pictures rather than lines. So what do these graphs give us? What information do they give us that raw data wouldn't? Or that raw data would be more difficult to get out of raw data? Well, graphs show information in an easy to read way. You can have information on a table like this, and you can just see numbers, and you would just see, oh, well, it's like a lot of 40s and some 50s, maybe a 20 here or there, but you the patterns need to be looked at a little bit closer at a table so that you can make conclusions or you can get other information from it. While a table takes that information, a graph takes that information from a table and puts it visually so that you can see the patterns that show up as you um, add more data points, right? So this tells you what it was at this date and what the high and low was for each different date, right? But here, this tells you how the temperature is changing over time, right? And so you can see on different dates the temperature changes. And you can see how the highs and lows get closer together or further apart on different dates. And you can make other inferences and other conclusions and other ideas about the information based on how it's shown on the graph. So graphs generally just let you see and predict patterns, right? So when we look at this graph, we have the value of someone's car, in this case Sarah's car, over a period of years. And at first her car is worth $24,000, right? In 2001, right? We look at 2001, our x-axis, we go up and we see at 24,000, that's what her car is worth in 2001. As we move on to the next year, we see that the price went down to 22,500. And as we go to each subsequent year or each year after, we see that the price decreases. And it's not a straight line either, right? You can see that it's curving downwards more steeply. The decrease is increasing each time. Right here we went down by about 4,200. Here we went down by just under 2,000. So you can see that the amount that the car's value is decreasing is increasing, right? It's going down faster as the years go on. And you can make a prediction on that. You can make predictions about, well, what is it going to be worth in 2008, 2009, 2010, etc. So this graph allows you to see a pattern and make predictions. Let's take a look at this graph. So we have different lines. We have the blue line representing the population of bears, orange for dolphins, and gray for whales. Well, you can see that in 2017 there were very few bears, and then apparently we had an overpopulation of bears, while at the same time the number of dolphins start to go down, and the whales tend to go down and up over time, not really changing significantly. And so you can see a pattern as if this line were to continue doing what it's doing, you would say the bears are going up. And as the orange line is going down, you can say that the dolphins' numbers are decreasing, perhaps even reaching zero. With whales, you can say, Well, they're pretty balanced, right? There are going to be some changes, but overall, it's staying at around 80, 70, around there. Now, a careful thing, just in general life, graphs don't necessarily mean the different categories, like bears, dolphins, and whales, are related, right? Someone could show you this graph and say, well, bears are eating dolphins. Well, that's not true, right? Bears don't do that. But this graph can tell you that the number of bears are increasing and the number of dolphins are decreasing. Yes, there's a correlation, but right, they're happening together. They're relating. Their numbers are related in the sense that one's going up while one's going down. But that does not mean that the bears going up is causing the number of dolphins to go down. So that's one thing you should be careful of when you see graphs later on, especially if you ever get interested in politics or information or data, because people will try and show you graphs and they'll say, well, these numbers are going up, these numbers are going down, but they really don't have anything to do with each other. But they'll tell you, oh, yeah, the bears are eating the dolphins, and that doesn't make any sense. It's only coincidence that the number of bears are going up and the number of dolphins are going down. So this is a term known as correlation does not causation, right? Just because these are going up while these are going down, that correlation does not mean that this is causing this. But that's just a bit of a life lesson. We'll move on to the math. So we have different types of graphs. We got bar graphs, double bar graphs, line graphs, double line graphs, pie charts, and pictographs. So the bar and double and line and double line, they're very closely related. They basically function in the same way, but with a small difference. Pie charts show proportion, percentages, so it goes back to probability in our grade 7 review. And pictographs are kind of a weird version of a bar graph. So we're going to start with the easiest one. We're going to start with one that everyone knows and has seen before, bar graphs. These types of graphs are used to compare, now hopefully my pen will work. Yeah, these types of graphs are used to compare different categories and collect information. So you can see favorite sport, you always have a title in your graph, right? Your title tells you what your graph is trying to convey. If you don't have a title, right? This could mean, oh, number of people who play the sport, or number of people who dislike the sport. So having a title is important because it automatically frames all the information you have here. It just immediately tells you, well, this bar tells you how many people like soccer, and this bar tells you how many people like basketball and tennis and hockey and baseball. So titles are very important because they very quickly tell you what the graph's about. So we can see here that most of the people like soccer, and then basketball, tennis, baseball, then hockey last. Or sorry, basketball, baseball, then tennis, then hockey. And the bars tell you how many, right? So on our x-axis, remember this is your x and this is your y, right? Do not confuse these because it's a very common mistake. And if you say, oh, my y is the categories of sports, well, that's wrong, right? So bar graphs use categories: soccer, basketball, tennis, hockey, baseball, right? These don't have values in of themselves, right? If I said Monday, Tuesday, well, no, Monday, Tuesday could work for other graphs because you could say Monday is 1, 2, 3, 4. But if you give discrete categories like soccer, baseball, basketball, or names like Jonathan or Stephen and Dennis, you're going to need to use a bar graph because there's no relation. There's no relation between soccer to basketball to tennis to hockey to baseball. They're their own thing. They don't change into the other. So when you're using discrete categories that exist on their own, then you use a bar graph because these guys aren't related. These guys aren't related. These guys aren't related. These guys aren't related. So you really can't have soccer changing or having a relationship with basketball or having a relationship with tennis or hockey or baseball. Other graphs we talk about, you could use a bar graph and you could use a different type of graph. And we'll talk about that as we do questions. So you can have bar graphs that are sideways. Basically, they took a bar graph, They took the x-axis, which would be here, and the y-axis, which would be here, and they just sort of flopped it on the side. You can see that sometimes. We're not going to really do that. We're trying to avoid that just so that people don't make the mistake of confusing the two axes. But here, again, a bar graph can only be made if you are looking at categories. If you are looking at categories. So before we had the categories of sports, now we have the categories of cities, right? Tokyo, Jakarta, Seoul, Delhi, Shanghai, Karachi. And on the y-axis, now this time it's flipped sideways, you can see the numbers going up, right? Tokyo and Jakarta, well, Tokyo doesn't change into Jakarta over time, or if you boil Tokyo, it doesn't change into Jakarta. They don't really have any relationship to each other. They're discrete, they're separate, they're individual. And so these are discrete categories. These are categories on their own. And so they don't really have any interaction with each other in terms of this graph. And so you'd use a bar graph to show the numbers of people in each city. You'd use a bar graph to show the numbers of people in each city. And you can see, oh wow, Tokyo's got a ton of people and so on and so forth. And then the bar graph can tell you how much difference there are between the cities and how it's changing as you go from one city to the next. So bar graphs can take information from a table, make it very easy to read, and allow you to predict patterns, allow you to make inferences, and allow you to make conclusions based on just the picture alone. So that's why graphs are important. So here we have a table that shows different categories and the number of people. Here we have fruit and number of people. So we have apple 35, orange 30, blueberry 40, kiwi 25, banana 10, and grapes 5. And with this graph, you can see, let's just say number of people who like the fruit. Okay. So we have 35 people who like apples, 30 who like oranges, 40 who like blueberry, and so on and so forth. Well, we can create a bar graph, right? We have our y-axis and our x-axis. Now remember, your x-axis should be your categories. So you want to label this as fruit. You want to label this as fruit, right? And then you're going to have apple, orange, blueberry, kiwi, banana, grapes, so on and so forth. And then you're going to have people, and I'm just going to put two P's and an L to represent people because I don't have enough room. People, P-P-L, people, right? And you'd have numbers ranging from 5, 10, 15, 20, and so forth as you go up. Now, a common mistake people will make is they'll just take these numbers, and put them here. They'll go, oh, well, if my x-axis is all the fruit, apple, orange, blueberry, kiwi, banana, grapes, then I can go 35, right? 30. Well, that doesn't make sense because it's not going up in any pattern, right? This y-axis, the numbers on the y-axis need to go up a certain amount. This is an oddly common mistake where they'll just transfer the x-axis here. That's fine. But then the y-axis, you don't just copy the numbers into the y-axis. You need to have a pattern. You need to have a set of numbers. You need to start at 0 at the corner and go from, let's say 5s, because we have 5 here. So we go 5, and then we have 10, and then we have 20, and then we have 25, right? And let's go 30 and 35, right? Let's do 40. Let's go all the way up. Yeah. Okay. So now we have a pattern that goes up on the y-axis. And then we can have our apples here. We draw a dot. Oh, no, sorry, not a dot. We draw a bar. And then if we had oranges, we'd go up to 30, like so. And blueberry, please make your graphs look better than this. It's an ugly graph. It's got a little bit of a belly going. We got 25, right? And we got 20. And then we got so on, so 10. And we have, sorry, this was 35. Grapes were 5. There we go. And so you can see a pattern forming. This is a terrible looking graph and it makes it hard to read when it's ugly. So please use a ruler, unlike I did. Please use a ruler to draw your axes and then draw your bars very neatly so you can see any patterns or relations that you can take from the data. So once again, when you make a graph, x-axis is your categories, your y-axis are your numbers, and you don't just copy the y-axis over to the the numbers to the y-axis. You need to go up in a pattern. You could go up by 10s. You could go up by 20s. You could, well, not 20s because you make really tiny bar graphs, but you want to be able to put a pattern, a sequence of numbers going up by 5s or going up by 2s or so on, and then creating the bars that go up to that level. So the numbers you put in here, like this number will represent the bar, not the y-axis. So 35 for apples will go up, this bar for apples will go up to 35, right? Not that the first number on the y-axis is 35. So here we have a view of the graph. Mine didn't really look like that because I just sort of rushed it. But you can see that apples are pretty high, but blueberries are the highest, and grapes are definitely the lowest. And you can see that people have certain preferences. You can use different colors to make things stand out. It makes it easy to read the data and just allows you to make inferences and conclusions much easier. So, we have a number of bed sheets manufactured by a factory. During 5 consecutive weeks, consecutive means in order, so 1, 2, 3, 4, is given below. Make a bar graph. So in the first week we had 600, second week we had 850, third week we had 700, fourth week we had 300, and fifth week we had 900. Okay, so we want to create a bar graph, so I'll just make a line here. So here we have our x-axis, our x values here. These are our categories, week 1, 2, 3, 4, 5, right? And again, I'm going to make an ugly bar graph. Please forgive me. So we have weeks, right? We have weeks. We have weeks. And then here, we have our number of bed sheets. Now remember, now if you look at this, you can see that the numbers aren't going up by any sort of pattern, like 6 to 850, then 850 to 7, then 7 to 300, and then 300 to 900. There's no pattern. It's not going up by 3s. It's not going up by 10s. It's not going up by hundreds. So your y-axis will be numbers of bed sheets manufactured. So we can just call them, we'll call them bed sheets. We'll just put bed here, save time. So you don't have to hear the clicking. We'll just put bed sheets here. And so here we have 600, 850, 7, 3, 9. Well, I want to go up by, I'm going to go up by hundreds, right? So I'm going to have 100, right? Even though there is no value here that is 100, I start at 100 because I'm just going up by hundreds. So I add another 100. I'm going up by hundreds, 200, right? I'm going up by another value, 300, right? 400, as I slowly click and click and click. 500, 600, 700, and so on. Now my graph's a bit small. I would have to extend this a bit more. So if I erase my Y here, 800, and then 900, way at the top here, 900. Again, please make your graphs better than mine. So we have, even though we don't have a graph value of 500, because we're going up by hundreds, we have to have a 500 there, right? These aren't the values from here. I just picked a set of numbers that go up by the same amount, right? I'm going up by hundreds each time so that now I can show my graph. So weeks, so first week, I'll put 1 as first week, 600. So I draw a bar to 600, right? And then we have the second week. Okay, 850, right? So then I draw a bar all the way up about halfway, and I go like that. I draw a bar down again. Not the best graph, but 700. So 3 would be 700, right? And then we have fourth week, right? Fourth week, we have 300. And then fifth week, we have 900. So just make some space. Here we go. And there you go, right? So we have our unfortunately ugly bar graph that shows us all the data. Now, you can see it's a bit harder to read. Why? Probably because my graph bars aren't equal size, right? This is a big fat graph, and this is a thinny wobbly one. You want your bars to be uniform. You want them to look nice. You want to use a ruler for your x-axis for your categories, and your y-axis for your numbers. You don't want to just plug in these numbers in the y-axis. The y-axis, you go up by a certain amount. And there's no real rule for how much you go up by. This time I went up by hundreds, right? 1, 2, 300, 400, 500. If this was, let's say, 60, 80, 70, 30, 90, I might go up by tens instead. So you pick a value you want to go up by that would fit all the data on the graph. Now you always want to try to start at 0 in the corner and then work your way up by a certain amount. So I could have gone up by tens, I could have gone up by 50s. I decided to go up by hundreds. You need to pick what values you want to go up by so that your graph fits and doesn't look stretched or short. And the values on here, the number of batteries sold, represent your bars, right? This was 600, so the first bar went up to about 600 right here. It should have actually been here, but anyways, right? So the bars are represented by this, not your y-axis. A lot of people will make that mistake, unfortunately. So there is another graph that could be used, right? The information we can make from this is that week 5 sold the most, week 4 sold the least, and there was sort of a shift, small shifts between 1, 2, and 3. But you can draw a different type of graph to show this data as well, and we'll talk about that in a little bit, that will show change over time, right? Because yeah, weeks are categories, but week 1 changes to week 2, changes to week 3, changes to week 4, right? They turn into each other over time. So you can use a different type of graph to show this. But because weeks can also be considered categories, you can use a bar graph. So here we have another one. The following table shows the favorite sport of 300 students of a school. So we want to make a bar graph of that. So I'll make another slide, another ugly, ugly slide. And again, these are our categories. And so if you're thinking, do I need to make a bar graph? Look at your x-axis. Look at your categories. Can your categories change into the other? This one's tricky because week 1 can turn into week 2. Over time, you can get to week 3, 4, 5. They are continuous. They become one another. They change from one to the next. Well, cricket doesn't turn into football. Football doesn't turn into hockey. Hockey does not turn into badminton. The sports aren't changing into each other. They're just different sports. They're their own thing. They don't really have a relationship to each other. So if you see this, you're like, oh, cricket, football, hockey, badminton, so on, they're just their own thing. Then you know you need to probably make a bar graph. So we would do again, right? Wow, let me fix that. Our ugly bar graph. Again, terrible, but let's, for time's sake, we have our y-axis way up there. We have our x-axis. We have our y, yeah. And so what do we start with our x-axis. Our x-axis are our sports. So we're going to put our sports here, right? Sports, with my awful handwriting, sports. Then we have cricket, football, hockey, badminton, swimming, tennis. So I'm going to put cricket as C, I would want you to write the whole categories, but for time purposes, I'm putting just the letters: hockey, badminton, and then we have swimming, so we have S, right? And then we have T for tennis. Now, again, um, not evenly spaced, not the best. You want to evenly space them. You want them to look nice. All right, so here we have our Y values. Well, not our Y values, but our bar values. So again, no consistent change. It's not changing by tens or fives or ones constantly. 80, 40, 20, 30, 45, 75. So what you want to do is, okay, what values do I want to go up by? Well, I don't go up by hundreds because 100 is above the maximum. I don't want to go up by ones because going from 1 to 80, that's a lot of work. I could go up by 20s. I could go up by fives. Fives might be a little bit much too. Or I could go up by tens. I'm going to go up by tens. So I start at 0 here at my Y. Then I go 10, 20, 30, right? 40. The numbers seem to be getting bigger, but yeah, 50, 60, 70, and again, I'll have to erase my Y here. And then up at the top, we have 80. Right? Sometimes you want to go up past your maximum, like I would go up to 100 so that the bar doesn't reach the tip of the graph. That's just me being picky, but yeah, you can do that. So we have cricket. How many people like cricket? We have 80 students. So we go from 80 all the way from here, all the way down. Right? We draw, it was almost good. It was an almost good bar. And we have 80 there, right? And then we look at football. We have 40, right? So 40, we have football here. So we go here, right? And then we have hockey. We have 20, so 20 people here. So you can see this bar graph's a little bit better than the other one. I'm trying a little bit harder to get it nice. Badminton, right? Badminton was 30, so we go from 30 to badminton. Now again, this might be a little squished. There you go. And then we have swimming, which is 45. So we go in between 50 and 40, right? And then we have tennis, which would be 75, which would be in between here, probably right around here. And there we go. And so now we have a bar graph representing cricket, football, hockey, badminton. Yeah, it was badminton, not baseball, swimming, and tennis. And you can see that cricket was the highest, football was sort of in the middle, so was swimming, badminton and hockey were the lower ones, and tennis was the second highest. And you can sort of see how people like certain sports, and you can use this as a sample for populations outside of school, and you get that information immediately, right? You could look at that graph and go, well, cricket's the highest. You may not know that cricket was 80 out of how many, 300 people, but you can just see cricket was the highest, and you can see tennis was second, and everything else was kind of in the middle. And so you don't have to analyze that much detail when you look at a graph. This bar graph tells you all the different categories and how many people like them. And once again, I really want to stress this, your y-axis, you go up by a certain amount. You don't just plug in the numbers. You don't go, oh, well, 20 is the lowest, so I'll start 20 here, and then I'll go to 30, then I'll go to 40, and then 45, right? You want to stay consistent, right? If you go up by fives, go up by fives every time. If you go up by tens, you go up by tens every time. So, line graphs is the second type of graph we could use. Line graphs are used to show changes over time or changes as something else changes. So here we have temperatures over time, right? So this would be in a day, right? At 9 a.m. all the way to 9 p.m. So we have 12 hours. Then we have degrees, unfortunately, in Fahrenheit, and we have plotted or put points in our data. And then we connect the dots. And so if we just had the table, you would just see numbers here and there at different times. But as you look at the graph, you can see that the numbers fluctuate, and the highest point is at 3 p.m. And then after that, it's just all downhill. At 9 p.m., it's the lowest, right? So you can make predictions on this graph. With a table, it would be harder to make predictions, right? So with a graph, you can go, oh, well, at 10, it'll probably be a little bit colder, right? And at around 8 a.m., it might be a little bit colder here too, or at around the same temperature. Here we have teens with cell phones and how old they are. Again, these numbers change into each other. Time, 9 a.m. becomes 10 a.m., 10 a.m. becomes 11, and so on. Right here we have 13 becomes 14, 15, 16. It's continuous. Each number is changing into the next. And so you can use a line graph. If your x-axis has continuous categories, the numbers or the values change into each other. So you can see at 13 about 229 teens have it, and then around 19, 642 teens have it. And you can make predictions on this graph. You can go, oh, well, it seems that the younger you are, the fewer amount of people have, or kids have, cell phones, and the older you are, the higher the amount of people with cell phones, right? Now, this is teens, so you wouldn't go past 19, but you can then say, well, for people 20 and up, you could predict that those people would also have a larger number of cell phones. And so you can make predictions on the graph, and you can see, well, 16 and 17 seems to be where the largest jump takes place, right? The largest jump takes place between these two ages. So these are the two ages where kids will get or buy cell phones. And companies can use this as marketing to create their marketing, right? They want to market towards that 16, 17-year-olds, or maybe they want to market towards those 13-year-olds because so few of them have cell phones. And so you can use this data, you can use the information, you can use the graph to make predictions, make inferences, and make conclusions. So here we have a line graph data, so data that can be used for a line graph, right? We have temperature changes over a period of time. Again, usually when your table, your x-axis will be your first column. You probably won't run into anything where your x-axis would be on your right. So your first column will be your x-axis. And so we'll have an ugly graph again, right? And we have days, right? We have days. Just going to put day, right? And then we have 1, and then we have 2, and then we have 3, and then we have 4, 5, and 6, right? And we have degrees. Again, these are where our plots or our points will be, right? They're not really going up by any significant or any consistent amount. So again, we want to start at 0 for a y-axis, and this will be degrees. So I'll just put, let's say, degrees. So I'll put 0. I'm assuming this is in Fahrenheit, unfortunately, again, right? And because 67 degrees Celsius would be crazy. So I'm going to assume it's in Fahrenheit. And so we have 43, 53, 50, 57, 59, and 67. So what numbers do I want to go up by? Well, what I want to do is I want to go up by, let's say, tens. Yeah, let's go up by tens. Right? 20, 30, right? 40, 50, 60. And it's going to be hard to draw because, again, a line graph, you need to connect the dots and it's got to look clean. Right? So first day is around 47, so I'll go right here. And then day 2 is around 53, so I'll go a little bit higher. Right? Well, that's too high. Right? And then we have 50, which is a bit lower. And then we have 457, right? So it's a bit closer, just a bit higher there. And then we have 5, we have 59, so just under 60, so just above that. and then we have 6 at 67, which is close to there, right? And so we can draw our dots by connecting the lines. Wow, that's terrible. And draw the dots connecting the lines, and we have a line graph, right? These are where we put our dots. 1 at 43, so around 43. 2 at 53, 2 at 53, right around here. You don't put these values in this bar. You sort of figure out a range you want to go up by, values you want to go up by here. So that's kind of what it would look like, and you can see it kind of matches. Again, in here I went up by 20, 20, 40, 60, 80, and numbers fit there. So you want to evenly space out your numbers and your values so that the graph looks nice. You want to make sure you have a title, right? And again, please don't make this mistake where you put the values here in your y, right? Your y is what you go up by. Your y values go up by a certain number. In this graph, we went from 0 to 20 to 40 to 60 to 80. We didn't have 20. We didn't have 80. So why would we put them there? We want to have a set of numbers that go up by a certain amount. So this one you can do on your own. The number of trees planted by an eco club of a school in different years is given below. Make a line graph. Again, our years change from one to the next. So you know you can use a line graph. And so you can plot this information using that data. Another one we can do is make a line graph from this one. We're going to continue on. I don't want to keep making line graphs. I want to move on to pie charts or circle graphs. These are types of graphs used to show categories and are used to show proportions. So pie graphs are used to show percentages or proportions, relative amounts, right? Here we can see that 30% of people like romance movies, and 20% of people like comedy, and another 20% like sci-fi. And so you divide up the pie or the circle, equal to the percentage. Right? Equal to the circle. And so this sci-fi pie slice is equal to 20%. This pie slice takes up 20% of the circle. So how to make a pie chart? This is tricky and kind of annoying sometimes because you got to use a protractor, right? You have your categories and you have your numbers. You need to find the percentages that each category takes up. So again, this looks very familiar, doesn't it? It's the same table we used for our bar graphs. And again, we have discrete categories. We have categories that don't become each other. Apples don't become oranges and so on. So we can also use pie charts when we have discrete categories. So first, you find the percentages that each category takes up. So the total number of people is 145. We found that out by adding 35 to 30 to 40 to 25 to 10 to 5, right? We added all of it up to get 145. Well, then we find the percentages. Well, the total number of people who like apples is 35, right? So to find the percentage of any number, you make a fraction. And if you recall from probability and our review of grade 7, making a fraction, you can turn it into a percent. So we have apples, which would be 35 over total number of people, which would give you 35 over 145. Then you multiply that by 100. So you put that in your calculator, 35 over 145. Then multiply that by 100, and you end up with 24%. Right? As a decimal, that would be 0.24. Right? And once you have your percent, you multiply them by 360 to get your angle. So we have apples are 24%. Oranges are 21, bananas are 7, blueberries are 28, and grapes are 3. So once you have your percentages, you multiply them by 360 to get your angles. Right? So this is 360, and you get your angles by measuring them out using your pie chart. So you survey your friends to find the kind of movie they like best, and you need to make a pie chart from that. So from here, you go comedy, action, romance, drama, sci-fi, and you make a pie chart based on the total number of people. So from here, we'll do this in class, and we'll cover that. Here, in a zoological park, there are 1,000 creatures as per the following table below. Make a pie chart from that. So we're going to be making pie charts in class, and we're going to be learning how to make pie charts from that. So pie charts and bar graphs both use the same data, right? Both use categories that are discrete, right? These are the same information, right? Just delivered differently, right? This one gives you bar graphs. These bars give you hard numbers, while these ones give you percentages. So, when would we use one or the other? Well, bar graphs are used when you want to show hard numbers, right? When you want to show 35 people liked apples, there it is. Pie charts are used for more relative things. You can say, well, a lot of people liked apples, and a lot more people liked blueberries. And you can see quickly, it's a lot quicker to see which one was the biggest pie chart, which one was the smallest part of the pie chart, and so on. So pie charts are good for quick, easy, general pieces of information. If you only want a little bit of information, if you want to know proportions or percentages, pie charts are what you use, right? And bar graphs are used for hard numbers, right? I want to know the exact number. Apples are 35. So double bar graph. A double bar graph is used when comparing two things with two categories, right? So we have two different categories. We have sports, tennis, swimming, canoeing, and crafts. And we have the two other categories of girls and boys, right? Red for girls and blue for boys. And these graphs show the comparison between the two, right? It seems here that girls seem to like tennis more than boys, while swimming seems to be equal, and canoeing seems to be more popular among the boys. And for crafts, you have girls liking crafts more than boys. This is not saying that this is true across, all groups, just at this camp, it just seemed to be true. And so we have this data, we have this information. So a double bar graph is used when comparing two things across different categories. We're comparing boys and girls across tennis, swimming, canoeing, and crafts. So double bar graphs, this is what a table would look like, right? You have the sport, tennis, swimming, canoeing, crafts, number of boys. And then you have sports. You have two tables here, sports, tennis, swimming, canoeing, crafts, number of girls. And you basically make a bar graph just for the boys, and then you make a bar graph just for the girls. And you have each bar for each category touching each other so that you can compare them directly, right? So let's say I just had just the boys for the information. I would create a bar graph like this, right? Just a bar graph here, and a bar graph here, and a bar graph here, and a bar graph here. And then I would create another bar graph, right? But on the same chart. And so you can compare them to each other. You can compare them to each other. And that way you can get information from different categories and different groups. It's the same thing, you just sort of make two bar graphs on top of each other. So make a double bar graph on this one. This compares the sale of ice cream flavors in 4 days. Make a double bar graph to represent that data. Again, you can create this, right? And you can have days, right? You're gonna have days, and then you're gonna have T, W, and then TH, right? For Monday, Tuesday, Wednesday, Thursday. Please make your graphs better than mine, but yeah. Then you have vanilla and chocolate. Well, I'm gonna go up by, let's say, tenths, right? I'm gonna go up by tenths. So we have 10, 20, 30, 40, 50, 60, and I won't be able to make my whole graph. I won't be able to make my whole graph because I don't have enough space, but we won't do the 81. So we go vanilla, so we'll make a graph, Monday, vanilla, so we go to 50, right? And then I make another bar graph for chocolate. So I'll use a different color, red. Chocolate's also 50, so I'd have another one like that. Sorry, it's really ugly. You want to space it out a little bit better. But then you'll have these two bars right there. Right? You'll have these two bars right there. And then for Tuesday, again, for vanilla, we have 60. Tuesday, we have 60. So we go to here. And then we have red for 80, which would be way up there. Right? 80, which would be way up there. And then you'd have Wednesday, and you have these two graphs next to each other, so you can make comparisons for each of the two graphs. Double line graphs, same thing. It's very similar to double bar graphs. You have two sets of data. You have two tables, and so you make a line graph for one, and you make a line graph for the other. And that's it. All right, so try and make a line graph using this data. It's the same one as this one. But because Monday can become Tuesday and Wednesday and Thursday, it's continuous, it changes from one to the next, you can create a line graph using, or a double line graph using that data. Pictographs are graphs that use pictures to represent numbers, right? Here we have January, February, March, April, and we have numbers of apples sold. Well, the picture of an apple represents a certain number, right? A whole apple is 10 and half an apple is 5, naturally. So you can show this, but it's basically just a bar graph, right? If I were to do this, you can see that it's basically just a bar graph. Pictographs are used for simple information, usually for children, to make things easier to understand. But they have other uses as well if you just want things to look pretty, if you want something to have a bit of more aesthetic design, then you'd probably use a pictograph. Questions here will help you practice, especially pie charts, on page 13, 4, 5, 7, 8, 10, and 11. See you next lesson, and hopefully this helped you understand graphs.